the best. I also just wanted to do a shameless plug, Purdue University Superheroes of Science on YouTube. Viewer, please, we would really appreciate subscriptions. To hit that subscribe button. We have weekly, we have a lot of different things, but we would appreciate your support for this. And we are going to be resuming our weekly Science Teachers Lounge again in August, and that's every Monday at 4 p.m. and we have our K-12 outreach calendar. You're welcome to join us. It's just a virtual chat room. It's a half hour, not a big commitment, just to talk about really anything, whatever. And we record them, and it's only audio. It's no visual, so you don't have to worry about showing up anywhere. But we record these, and we do have a playlist for our weekly virtual. Well, I always say it wrong, and then the marketing people get on me. It's our podcast, right? It's only audio, not visual. Also, we have a Facebook group on there, and we have our Superheroes of Science page. So off of our page, we have our K-12 virtual science group, where we have several teachers on there that we're trying to get that started with sharing some ideas and things. Also, be sure to subscribe. Again, that's Purdue University Superheroes of Science channel. We're going to be running a video this August where we're going to be doing a giveaway for some Arduino kits, some student kits for Arduino. So be watching for that. Again, that's coming up in August. We're going to switch over now. It's 11:02, and we're going to be sharing with you. I'm going to put that in the chat now. This is our Gateway Mission Lockbox. So we have come together. We're making this a little integrative. We're putting up math with a lot of the science standards that we'll be teaching the rest of the week. And we made this specifically for middle school. So it's really spanning grades 6 to 8. We've done quite a bit with lockboxes, both virtual lockboxes and in-person lockboxes, I guess paper and pencil, over the last few years with a lot of success. And we always mention that we begin our lockboxes with our goal in mind. What is it that we want the students to get from this lesson? That we're not just building these lockboxes as an entertainment piece, although I gotta admit, it's nice to have this occasionally to give you a break, like, oh good, I can give this to them, it'll keep them busy. But we really wanna focus on, getting them, the reason, those goals behind why we're showing these lockboxes. So you're welcome to access this, and we'll be, Bill, this is the link that we'd like to include in the plan as well. We said we'd release that today when you joined our lesson. But Brooke joined us, and we also worked with our K-12 outreach coordinator for the Department of Earth, Atmospheric and Planetary Sciences, Stephen Smith, and he will be joining us later this afternoon. We worked together as a collaborative effort, and we're going to take you through that now. So I'm going to go through and do my screen share. And I just need to remember, let's see, Bill, do I have that permission?
I don't think you need to be.
You should have that permission. Is it down at the bottom?
Should say share.
Yeah, it's grayed out right now for share content.
Wait, let me go back up. I don't know why. You should have, hang on one second. How about now?
Yeah, I got it now. Perfect. Okay, thank you.
Yep.
And let's see, we're going to share. Okay, let's see here. Share. Okay, I don't want a whiteboard, and it's telling me share a file or share a new whiteboard. So do I have other options?
Are you asking me?
Yeah.
Oh, sorry. I thought you were.
Maybe there's a setting in there that allows you to let us share our screen as well.
I've got you to be able to share. Let me go one more thing here. I don't.
We can see the whiteboard.
Yeah. I don't want to share the whiteboard.
Because I have you sharing all, you're able to.
Okay, you know what? No big deal. We don't want to waste any more time here.
Yeah.
So we're going to go ahead. I'll just look off of this and we'll just describe it as best we can. I'll use all these audio skills I've learned from our Teaching Science podcast. It will be resuming again in August at 4 p.m. on Mondays to hopefully give you, and I'm going to try to quit sharing this. No. Okay, there we go. Quit sharing. Hopefully you don't have to look at an ugly whiteboard anymore.
Well, were you all able to access the document? If not, then just kind of put a I need help. Okay, so
Michael, I saw your thumbs up, so
All right,
that's good. That's good enough for me. All right, thanks. Here we go. We've got, here's our backstory for this. In a secret location somewhere around Cairo, a paleontologist and anthropologist discovered an artifact that predates human civilization.
And you have been assigned to this top secret government project, and everything contained in these files is highly classified.
Physicists have discovered this artifact is actually a series of 3 gates that will transport people and items beyond our Milky Way galaxy.
Your team is tasked with finding a planet within these other galaxies that is suitable for both research and human survival.
So here we go. We've got them hooked now, right? And we're going to begin with, I have linked on this, right? This is our Google Master, our Lockbox Master that we have that we found very helpful when we're designing. So we know our goal. We know what the students want to get out of this. Now we need our map so we don't get lost and we don't lose combinations and this sort of thing. And what we've got here is I've got a forced copy of the Google form. I wanted to show that, but hopefully enough people are familiar with this now that you can force a copy. It's going to put it automatically in your Google Drive, and that way you don't have to worry about saving it to the right spot or anything. But you've got under teacher links, the Gateway mission. The very first link is that Google form. That's the editable one. Now what I did on the middle column right next to that under student links, I went ahead and put an example of a student link to this. And this is, you want to make sure and give students a link to your Google form so that you can set up your spreadsheet and get their responses if that's something that you're wanting to do ahead of time. This is just an example for illustrative purposes today, so you can see what it is when we get on this. But we're going to go ahead and click on the Gateway Mission Google form. That I'm going to click on the student link that I'm walking through. And let's see, I'm going to copy this again. I see someone just popped in that they got on here late and they might not have that form again. So here it is again, just in case you missed it the first time. But what I see on this Gateway form, this is all that the students are going to need, and it's going to direct them to other links to other Google Jamboards they're going to be able to see, to be able to find the clues and instructions to get them through these 3 gates and find the planet that they need for to do the best research and survive as humans. So first thing, you're going to get a scary screen that says, do I really want to make a copy of this? Well, you know, probably if you're clicking on it, you probably want to make a copy. And like I said, that's going to get it into your drive. And then I have it set up right now to go ahead and collect student emails. And we're going to go ahead and just put in, Brooke's going to put her email in. I know you can't see this because, but maybe you see it on your own. So you're working through this alone.
So are you supposed to have them do that? Or?
Have them do which one?
Cut and paste into your story.
Oh, okay. I'm going to fix that. I thought that it was, oh,
Wait,
you know
wait a
what?
minute.
I know why it's doing that. This is just, so this that you're seeing right now is just an example. And I had already put the intro story in this. You know what? I'm going to get on. Let's go ahead and change that. No, I'm not going to worry about it right now. That will be different. This is just an illustrative link right now. And I had made some changes to the original. So you should be, it should be okay for you when you go now. But anyways, we see our gateway artifact and we're going to go to next. And we get to our very first puzzle. And so the very first puzzle, it talks about in a secret location somewhere around Cairo. We see all that beginning story again. But we're going to click on the link for a Jamboard. And this first activity is we're going to be plotting on a set of axes some different points. And Brooke, you want to talk about this one?
Yeah, so what we were thinking here, so one of the 6th grade math standards involves plotting in the 4 quadrants, right? So not just thinking about positive X and Y values, but including the negative values. And so we thought it would be kind of fun, I guess, to plot some different constellations and then use those graphs to identify which constellations you have plotted. So this first gate 1, you're going to use that to kind of help you figure out the code to get to gate 2 and then so on and so forth. So the 3 gates, remember? So this is all gate 1. So for this Jamboard, you're going to plot those 6 constellations there. So if you have students working in teams of 3, maybe each student plots 2. If you want to give this to students and each student do them all, I think there's lots of different ways you can see this happening. If you want to do it pencil and paper, then you just want to make sure you have a page that has at least 15 units in each direction. That way you can get all 6 constellations on there, or that if you want them to scale it. But if you want to do it digitally, we're going to do it digitally here today on this Jamboard. So if you want to pick a constellation and start plotting it, we'll give you a few minutes, I think, to do that.
So,
right? So
yeah.
let's see if you have a minute. So you'll notice that there are some constellations only have 4 or 5 points, and then some have up to, I think, 10 or maybe even 15 points. So if you're feeling ambitious, maybe constellation 5 is the one you want to plot first. If you're just kind of new to this Jamboard idea, maybe constellation 4, it's got 4 points there. Maybe you can start with that. So take a few moments, start plotting them. We'll give you, so if you want to use the pen, So you use the pen, and I went to like the marker mode of it. So the pen, and then the second one is the marker, and then just chose a color and marked each point first. And then once I had my points, then I made my line segments to connect them. So we'll give you a second to plot the points, then we'll talk about how to connect them in a minute. So go ahead. If you have questions, you can put them in the chat.
Right.
It's flashing.
We'll address these. I'm fixing the links right now in that, and I'm just going to double check that that worked. So.
And Sarah, they're saying they can't get the link to open. Is that what you're trying to do right now?
Yes, I just stated the links, and I'm going to double check that they worked on.
Thank you, moderator Bill.
Yes. Yeah, and I think if they refresh now, the link should work. They're going to get a copy under the teacher one of the form that they can then edit, make their own edits. They can set up a spreadsheet to collect responses, and it does have our story behind it. And then I just want to make sure that the example student link that you'll want to be sure and switch out. You won't want to share this student link. Just double checking that it works. Okay, good. Yeah, I think we're in business now.
So we tried to check everying, but
yes.
You know how that works, right?
It's like I always feel like my first hour kids. I feel bad for you because I'm making all my mistakes with you, right? but yes, can't get the link to open. Suggestions. Andy, I just disconnected the links and reconnected them. So I don't know if you want to try refreshing the page. I just pulled it up and everything is back in working order now. And you will have to save a copy to your drive. It's going to force you to make a copy of that. Okay. And then okay. All right. And I'm going to, I'll copy over again one more time, just in case anyone joined us late, the link to our master where we have all these things. So you might just try getting on this again. Okay, so hopefully that. All right, Brooke, you want to tell us?
Are we ready? Do we have any plotted?
Yeah.
Ready to connect? Okay, so if you've got, I'm going to talk about constellation 1. So if you've got your -11, 1 and -13, 0. So if you want to connect them, you will use, so you can still have the pen tool. So you're going to hold shift, and then you're going to connect one point to the other, and then it'll make a nice line segment. So you don't have the wobbly lines, right, going from one to another. So again, you've got your points plotted, and then you will hold shift first, and then go from one point to the next and then drag it to the next, and then it should connect them. So go ahead and connect all of those as you're going. So you want to connect each one to the one after, and then if it indicates that you might have to connect it to a different point, back to a different point. So like constellation 5 has one that you have to connect back at the end, constellation 2 and 3. So to kind of finish out the constellation. And then once you have it plotted, you're going to look at the constellation. So we've given you a few different skies. So if you look at the Jamboard on slide 2, you'll see the northern hemisphere summer sky with the different constellations there. And on slide 3, you'll see the northern hemisphere November sky. And so using those two views of the sky, you're going to identify which constellations are there. And then we did add, and okay, so I'll give you a few more minutes to do that. Or another minute or two, maybe. We could share the screen.
I know.
That would be helpful.
Didn't anticipate.
But this is what you do, right?
That's right. Yeah.
You just figure it out.
Good
So
with it.
sorry that we can't share a screen right now. Hopefully, maybe we can get that fixed. If not,
We're working on it.
It'd be really cool if you could share your screen and show us what you plotted. But
That would be so cool.
Yeah,
Might blow WebEx out of the water though.
But I'm thinking, you know, as students are doing this, they can use the Jamboard to plot them. You could have them plotting on your whiteboard in your classroom. You could, you know, make your ceiling into a coordinate plane, and you could put the constellations up there. I mean, you could do lots of things, I think, with this. This is just a way we felt like we were able to like, get you to access it kind of easily. And so that's why we chose to use this format.
Sarah, I may have just allowed you to share your screen.
Oh, that would be awesome. Okay, let me try. All right, let's see. Oh my goodness,
Okay.
yes. Okay, I see it.
Share it.
Let's see. I'm sure. Okay.
Yes,
Yeah,
we can see it.
Good. So I want to try the different. Go. That's what I was wanting.
The key, yes.
Yeah. And I have. Okay, here we go. So here we are, and we're gonna. Oh, I'm so glad I can do this now. Thank you. Here we go. So I'm making a copy. We're going to jump to the constellation identification key that, again, is on that copy of the Lockbox Gateway Mission Master that we have that's kind of running us. It's like our roadmap, right, for navigating the Lockbox.
Yeah.
And here you're going to see on screen 1.
You take it
that
for
we have, what's that?
You could if there's no other dogs in the dog park.
Oh, dogs in the dog park, huh?
Make sure you. Oh, my bad.
Oh, no. All right, so here we go. Here is we just so you have them for your reference, and you know sometimes you just need those answers quick. We went ahead and showed you what all those plotted constellations look like, and then also you're going to see I don't know if you can see my mouse moving here, but the constellation names. So we are definitely going to need those, and the students are going to be able to use the next 2 slides. We have a snapshot of the summer sky in the northern hemisphere because Cairo, Egypt is in the northern hemisphere. But then we also have constellations from the November sky in the northern hemisphere. We did a mix of both of them. You could always modify this. You could do your own constellations where you could choose just one sky, maybe just November constellations, or really any time of the year. Brooke found a great resource that you may or may not know about. And again, this is a slide here in your constellation identification key, but it's called Sky and Telescope. And we have the web address for it as well. But you're going to be able to go to any sky, any time of year, any sky based on the GIS coordinates, so the latitude and longitude, and you're going to be able to plug that in, or even a zip code, and it's going to show you based on the time of year, and really, I think you even put in the time of day.
Yeah, whatever day, whatever month, whatever time, all of those.
All of those, and you're going to be able to see those constellations right there on that screen, what you would be able to see from that point looking up at the sky. So if you didn't like our constellations, or maybe you wanted to challenge them, or maybe they're too challenging and you want to modify them a little bit, you could find your own. You could roughly plot them out, give the students the coordinates, and then direct them to a snapshot of the sky and have them identify those shapes. But if you're using our constellations, this last slide, we're going to show you on the left, you're going to see the names. It's those names then that we're looking for in the word search. Now, the student view of this, what the students get from clicking on the link in the Google form is they just get a blank one of this. So they're going to be able to come over here and use their pen. And they can either use the pen, they can use the highlighter. And I love the idea of using a word search on a Jamboard because they can go through and they can do it. They can erase mistakes. It's just like having a sheet of paper in front of you, but it's all virtual. And what do you notice about our answers here? So Stephen is the mastermind behind this word search that we have here. It's giving us a code, and it's that code that we want to plug in. Oops, I'm back at my start here because all right, just gave you my personal email. There you go. Okay, here we go. So again, that link is what took us to the student Jamboard view. It's going to force the students to make a copy of their own.
And so what we were thinking kind of as we went through this, so again, like plotting the points in all four quadrants, right? So thinking about all of that, and then also tying it with the constellation, so identifying those constellations, but we weren't really sure how to kind of take it to the next level, how to get to the next one. And that's why we decided the word search might be good, a way to familiarize themselves with those constellations a little bit more, and then turning it into the code to get to the next gate, right?
Now the next gate, we are at gate 2, right? Congratulations, you got through gate 1. Now we have a second Jamboard that we're going to direct students to. So I'm going to go ahead and click on that. And now our topic is going to shift to geologic time scale. And I believe that, there we go. So here's my copy, and we're going to see this geologic time scale. It's in order here. This is our second gateway. We said scientists are credited with discovering this artifact, uncovered fossil evidence indicating that it first arrived on Earth about the same time as the first land plants. And that it's a literal gate that measures a length of 4.6 meters that contains symbols representing important events in the that's a good question. Here, we'll get back to the practice Jamboard here in a minute. But that it's of Earth's 4.6 billion years of geological history. And so really what we're wanting to think here is that 1 meter is going to go with about 1 billion years. And what we'd like students to do because you're going to see on this form that they have 2 questions they're answering now, right? So they need to go to this Jamboard to be able to answer these 2 questions. And the very first question goes with the first slide, but they're going to begin with finding this distance along the second gateway in centimeters to the symbol for the first land plants. So we're going to give you a minute. Are we doing okay? Yeah, gate 2, we're right in our time window, so we're doing good. So I'll give you a couple of minutes, and if you want to work ahead and look at the next slide, and then here about 2 minutes, we'll go through some of these solutions and move on. Oh, and then while you're working, I will flip back to chat, although I don't see it.
And Sarah, so
Yes.
the question that was been asked is they've not used Jamboard before. Is it pretty easy for the students to catch on?
So
Should
I
they
was
do
thinking that I had heard about Jamboard from my colleagues and I'd never used it myself. I'm kind of like pushing back on Google a little bit, but I need to kind of suck it up. I love my Microsoft, I love my Word, but I have found it very easy to use. And I think just like with anything, the students are probably going to catch on faster than we are. And so I think that it will go smoothly.
What's nice about a Jamboard, and maybe not necessarily the way we have this one set up, but you can have a whole ton of students all on the same Jamboard, and they can all be like working through a problem, or like even on that word search that we had, they could all be looking for a word search, potentially all in the same one, working together as a group.
They could each be plotting their constellations together, and then if they start to overlap, they could say, oh no, maybe we're doing something wrong, right? They can kind of check themselves as they're going through.
And I like that kind of peer check as they're going on. I think we do that a lot anyways with whiteboards in the classroom. This is just a different way of doing it. It's a virtual way of doing it as well. well. So if you have to be virtual, it does kind of provide that social interaction, through the Jamboard. So I do think the students would catch on fairly quickly, and there's not a lot of ways to make it complicated. So really, it's a pretty cut and dry. You got your pen tool, you have your
It doesn't have as many features.
mouse. Yeah, there's not as many features. I see 1125, so we're going to start going through the solutions for this one to get us through. Do we have a question? Oh, no, okay. Yeah, so if we're starting at today at the very top, and we see today would be time 0, and we're working backwards, and we see that the first land plants, and since I'm on here, I'm going to go ahead and use my pen. I see my first land plants right here. And that is, I'm reading 440 million years ago is the first land plants, but that's not quite a billion years. So if I'm thinking about a meter, and I'm not quite at 1 meter, but I'm at 440, what am I in? Or how would I describe this as my distance? And so I want my distance in centimeters. So how many centimeters would it take to get there? All right, yeah, 44. Andy, I see Andy Middleton. You say 44. Okay, there we go. So we're going to type in 44 for that one. And then on slide 2, we have our next one. So here is, do you want to talk about this one?
Yeah, so we were thinking about how to tie in kind of the idea of ratio. So we're thinking about, you're making a timeline, you're thinking about plotting like a linear distance, right? And so we're also thinking about this idea of ratio. So we're thinking the time that it took for the first land plants here continually repeated itself, right? So I'm thinking about this idea of a ratio. How many times would it completely repeat itself before bacteria are first found? So we'll give you, do we want to give them a second to think about that?
Yeah.
Okay, we'll give you a second to think about that, and then we'll come back in about a minute to catch up.
Okay, you want to go ahead?
Yep. Okay, so hopefully if you're looking back at the chart on slide 1, you saw that the Paleozoic era was like 330
million.
Yeah, we want to go to that, land plants to bacteria, right?
Right.
So land plants were the 440 million, and then bacteria come in at 3.5 billion years, right? So how many times do we think about that being repeated over and over? So we think about the distance, or like we divide those two, right? So we think about 3.5 billion and we divide it by 440 million, and then we see how many times, right? So you divide that and you see, oh, it's like 7.95 times, right? So I can repeat that.
Just to stop too. So 3.5 billion would give us about 350 centimeters.
Oh, yeah.
Where to the first land plants, it was only 44 centimeters. So that's quite a bit farther before we first see bacteria showing up. So 44 centimeters for our land plants. How many 44 centimeter iterations are we getting until we get to the word bacteria first appear?
Okay, thank you. So we think about dividing that, right? So we think about the 350 centimeters divided by 44 centimeters. And so we see that it ends up being 7.95-ish, right? And there's a little more there with it. Okay, so it'd be almost 8 complete sets of these land plant times before I get to the bacteria. But we asked, how many times would it completely repeat itself? So this is where we have to kind of think a little bit, well, is it going to complete itself 8 times? Or is it going to be 7 complete times with almost another complete one? So we want to kind of have the students think about that a little bit, like about their rounding, right? Like, so normally I would round this to 8, but in this case, the way the question's asked, I don't know that it's going to give it to me. So if you put in 8 into your Google form, I think we put a little hint there.
We did, yeah. So I'm going to go ahead and put in 44 for my distance. But then I'll say, oh, 7.95. Okay, I'm going to go with 8. And I go to click next. Well, 44 must be correct because I'm not getting an error message. But here I see this hint, right? Are you rounding?
And so we didn't want them to round like in the traditional mathematical way, or we're thinking about the complete cycle. So it should just be 7 complete cycles of the land plants before bacteria came, which is crazy, right? To think that 7 sets of those before, like that's a lot of time, right? And so I think that we thought that was kind of an interesting thing to think about.
You could definitely add more of those in. We have these 2 questions in, but again, you can edit this Google form to meet your needs for what you want the students doing. I liked that it emphasized what a unit ratio is in a real life situation. And I also really like this spin on rounding, because I'm with Brooke. I think traditionally we would have them round up, 7.95 to 8. It's just thinking about a different way of rounding. Like, no, we want to know how many times are we completely repeating ourselves and going with that 7. So let's try it again. Perfect. Okay, we get through gate 2. Yay, we made it to gate 3. And now we are switching topics again. We're going to be looking at finding some volumes of air masses above fields. And so we have this next part here. We're saying, okay, yay, we got through our final gate. This gate has a holographic projection of a solar system with 3 different planets. And we have to determine which of these 3 planets will make an acceptable research location. So when this alien sun rises on each planet, different amounts of energy are absorbed or reflected based on the surfaces of the locations. So each of these locations have 2 very distinct fauna. One is really dark and absorbs a lot of energy, and the other is very light and reflects a lot of that light. And if the ratio between the dark and the light fields, that energy ratio is too great, the shear winds that develop from those convection currents will be too strong, and they'll tear apart our research equipment, not to mention the environment will be pretty hostile for human life. So what we want to do for each of these next 3 fields, and we're going to go to a third Jamboard, this is our final Jamboard that we have, is we want to calculate the ratio of light field to dark field air mass volumes for each planet, and then we want to report those calculated ratios below. All right, so I'm going to go ahead and go to force a copy of this, and let's take a look at what we're doing here. And Brooke, what would you like to start off with on?
Well, so as we were thinking about this, we wanted to think about these air masses, right? We're trying to think about the volume of these air masses, and so we wanted to bring in some of the Pythagorean theorem, right? That's part of the mathematics standards in middle school, and so we felt like that might be a nice way to kind of tie in the mathematics with this air mass idea. So we're going to give you a minute here to think about planet 1. So you've got some different values here. So we're going to ask you to find the air mass volume of the light field and the dark field, and then you're going to find the ratio of light to dark. So we'll give you a couple of minutes to do that. There's 3 of them, so pick your poison. I guess you can do 1, 2, or 3, and then we'll share kind of the results and talk you through the rest of it here in a minute. That's right, play music.
Right.
Some on hold music.
Elevator music. How's our comments, Bill? Do we have any comments to address?
Not right now.
Okay.
And just a reminder, you'll see all of these keys and the student copies in that
Gateway Mission, Lockbox Master. We've put it a couple times in the chat. And I sure hope all the links are working now. They should all be, they look like they're working to me when I took a look. So.
We've got those answers in there, but then in the Jamboards, we have separate, like more complete answer solutions for you. So that don't just have the codes, they have kind of the mathematics and science thoughts.
I think so. We'll go ahead in with the.
All right, so let's see if you've got anything. So for that first one, so you're, or hey, let me pull my key. There we go. So the first one, you saw a side length of 40 kilometers, a diagonal of 41 kilometers. So using the Pythagorean theorem, you will end up with 9 for the other dimension of that rectangle. So then you have 40 times 9 times the atmosphere height. So you see the atmosphere height up there in blue. And so you multiply all of those together and you get a volume of 3,600 cubic kilometers for the light air mass. And then the second one, so you get 8 for your other dimension, and then you multiply by the height, and then you get an air mass volume of 100 don't know why I wrote 11,400. I don't think 15 times 8 times 95 is that. But your ratio should end up being 3. So I'm not sure where I 3,600.
No, that's right. 11,400.
Okay.
Yeah.
Oh, then maybe I forgot. Did I forget a 0 in the first one? 9 times 40. Oh, 3,600 and then times 95. That's where I forgot. 3,600 times 95 is. And then. So this one. So that's 36 or 360. And I should have taken times 95, not times.
Oh.
There we go. 34,200.
Is this the actual original?
Mhm.
Okay.
So
we're adjusting those answers as we work through them. We'll get it figured out.
I know, I tell you. You too could be an outreach coordinator. So that's what my friend used to always say. Because, you know, I mean, as teachers, we're all still learning. We're all trying to figure things out, right? So, okay. So you found the first one, the area of the base to be 9 by 40, right? 360, and then the volume or the height to get the volume. So you end up with 34,200 and then 11,400. So then the ratio of the two becomes 3. So we did end up with nice whole numbers. We did trade you that. So then if you moved on to the second planet, maybe you did that one. You saw 37 and 12 were the dimensions given. Well, the diagonal doesn't help me get the volume. I've got to find the other side length. So you get 35 for that. You find the volume for both of those. And then the ratio on that one ends up being 1. And then on to the last one, the ratio ends up being 5 for that one.
So we're going to go back to our key. So again, we've given the students a diagonal. We've given them one side of a right triangle, both for the light field and the dark field. So they're using Pythagorean theorem to find that missing side. And then they're calculating the area of each field. And then they're multiplying both fields by that atmospheric height in order to get our volume. And then what we're doing is we're taking that ratio between the light field to the dark field. So we see between our 3 fields, we have one ratio, that planet 1 is coming out as a ratio of 3. We see the middle field, planet 2, has a ratio of 1. And then our third planet has a ratio of 5. And these are what we're then plugging in.
So remember our story said that we needed the smallest ratio between the two air mass volumes in order to be a suitable place for equipment to do all of this transporting to their galaxy.
Right.
And so then we're going to go in and we want the lowest, the second lowest, and the highest all reported there. And then we have, okay, like which one do you want to use?
So which one would you recommend using for our research outpost? And we have 3 options. And really, this is kind of where it gets exciting, right? I don't know, maybe. And this is sort of how the students then interpret this. But I don't know, what do you want to say, Brooke?
Let's say, 3 has a 5. Let's do that.
Okay, 5 sounds good, right? 5 is my lucky number. I like 5. We're going to go with planet 3. And we chose planet 3. We see our original mission. When the alien sun rises on each planet, different amounts of energy are absorbed or reflected based on the surfaces. But 5 is too high of a ratio for this. Our shear winds from the convection currents are way too great. It's going to tear apart our research equipment. And humanity will not be able to survive. So, oops, I'm game over. I did not pick the right planet for this one. I don't know how to fix it, or maybe we don't need to fix it. I'm probably just being too picky about going back. So we see this is a back function. I don't know. I tried Googling it. I don't know how you get a Google form where you can't go back. But if we went back, let's say that we go with planet 2. We'll work our way up. There, I win if I go here, planet 2, because planet 2 is where our ratio is 1. That's where we're going to have the best ratio of light to dark. Our shear winds are going to be within the range that we need to support our research equipment. Humanity is going to be able to survive. Here we go. I'm going to be good. Now I'm just curious. I want to know, what if I chose planet 1? Because I see I lost, I won. And planet 1 is not ideal. So I don't win, but I'm not necessarily killing off all humanity either. So it's kind of like, well, your shear winds are still going to be too high. From these the convection currents are still a little too great to support the research equipment. You could survive. So we see these little people here, you could survive. It's going to be a really harsh environment, but I like bringing in this idea of energy as feeding into these shear winds from convection currents. And we'll talk about convection currents later on. I don't think it's today that we talk about convection currents. I believe it's Thursday that we get into those. But how convection currents are related to energy and why, but it's all connected. And I like this idea and this critical thinking of the students to think about, which ratio is gonna support these this good environment that we need for researching on this alien planet. So there we go. That's what we've got. We'll go ahead and submit. And we just see the ending. And again, this is editable. You have the links to make this your own. You can add in other constellations. You can make them all from your location in your hometown, right? We can go to that sky and telescope. We can find our own constellations and then plot those if you wanted to change those. But we like this because we feel like it's tying a lot of those middle school standards together, and it's integrating those math concepts that they're already learning and having them apply those in a pretty cool way. So we have 10 minutes left in this presentation. Brooke, am I forgetting something? Oh, I saw a comment.
Oh, to print out and do it in person.
Oh,
yeah.
Yeah.
So I think I worked in a school where I didn't necessarily have the best internet access. And so I would print things out and a lot of times and do things. So I think this is something you can do in person. You don't have to have technology to do it. You can print all of these things off. I don't know if do they have a master document for that, or it would just print off the Jamboards? I
think right now I'm thinking probably print off the Jamboards. We don't have the master copy to print that off yet, but I'm seeing you received, if you're, some of you may have received the actual boxes and locks, or unless you're, unless you didn't sign up to be one of those, and that's okay too. You don't have to have anything fancy. Really, you can just use envelopes. You can use anything. You can use an empty drawer as a lockbox. But we could definitely print these puzzles. We could print off grid paper. The kids are probably used to plotting things on grid paper anyways with a paper and pencil. We were excited about this lockbox activity because it was the first way I've seen of actually plotting points by hand, you're right, or as much by hand as possible online. So I don't know, other than an Excel sheet.
Just already plots the points for you. So we wanted to find something where you had to plot the points instead of just entering a coordinate and then letting it plot for you.
Right. So we like that idea, if we're going to make it virtual, that we could do this, but definitely paper and pencil. The lock boxes are great because then the kids are they're getting that code. Let's say the very first code, the 1741, they're plugging that in, and then they can get that next worksheet, the geologic time scale. We could have all that in that first lockbox so that they could get that puzzle out, and then they're taking it back to their seats, and then maybe measuring out on, or maybe we're pairing it with another geologic timescale activity, like maybe one we'll be talking about tomorrow, that they're already doing these, but they're paper and pencil doing it instead.
Yeah, and I think that's kind of maybe also a good tip to give, like where the lock boxes would come into play is after each gate. So after the first gate is where they would go to the first lock box, and then after the second gate, they would go to the second lock box. After the third gate, then you would figure out something to do for them for the ending. But that's kind of how our thoughts kind of go with the virtual lockbox versus the in-person one.
We've had locking cabinets before where they've had to find a key and then go and unlock that. And you think about like an escape room or something, it's similar to that. But again, it's not, and I just want to emphasize again, we're not doing this just for entertainment purposes only, that we really are having this we're thinking about the learning outcomes for our students in doing this lockbox, right? We're creating this with a purpose. We want them to be able to understand, it's really driving home that plotting points, using that to, look up these constellations, using the geologic timescale, right? Unit ratios, developing ratios, and seeing how these apply in real world situations.
And the Pythagorean theorem and the volume, right? So these are math forward maybe, but with a science like connection, they're all connected together. Oh,
I missed a comment. Can we stop?
Yeah, let's stop sharing.
Yeah, maybe. Stop sharing.
All I said, Sarah, was that if they paid to be a part of this, the locks were shipped last Friday.
Yes.
Gotcha. So yeah, if you have any other questions, I think that these last 5 minutes we'll use to kind of answer any questions you have or any thoughts. We had some other thoughts on how we could modify this if you're thinking about maybe just doing one activity and not doing all three at the same time. So we can share that with you if you'd like. Just tell us what you would as you're thinking or as you're typing maybe. So one thing I was thinking about with the constellations is maybe they pick their favorite constellation, they plot it themselves, and then so they could create kind of like
kind of work backwards. Yeah, that's a good idea. And that might be a way of using that sky and telescope as well. Like I like that kind of inside out plotting. So you're starting with your shape and then thinking about what each of those coordinates would be to make it. And even having then another group plot that, right?
Yeah,
to see. So then that's some feedback.
Their own.
Mm-hmm.
I also think like the timeline. So thinking about that 4.6 meter piece of paper, like plotting different things on there, I think could be really interesting. So maybe you spend one day where they're just plotting all these different eras and where we found land plants, whatever. And then the next day is when you enter with this lockbox activity, right?
Mm-hmm.
So they already have it kind of displayed, and then they're going to use that information later.
And we will be covering that as well. We do have that activity.
We do want to remind everybody that we did record these and they will be put on the Google Sheet so that you can go back if you want to relook at and relearn or just refresh your mind again one more time.
Or share with the math teacher.
Yes.
I do like the Google the sky. I like the what's that called, the sky map one. Again.
Yeah, sky and telescope. Mm-hmm.
Yeah, I like that. I like pushing kids to that site because that way they start seeing and start thinking about the constellations and the fact constellations are different at different places on the Earth at different times. And so that I think that starts building foundations for them to understand our astronomical location of the Earth itself and how we're changing, which helps them also, I think, lead into obviously moon phases, seasons, tilt, and things like that. I think by them seeing that and starting to make those connections, I think it helps them out a lot with the other standards that we're instructing.
Yeah, and I think it's really interesting, especially if you think about students, maybe, so like not all of you are necessarily in the middle of nowhere where you can see the stars every night, right? Like I went to a graduation party last weekend and this boy was from New York and he had never seen stars. He's like, I don't even know what it looks like. So like the fact that you can go to that Sky and Telescope website and see what it looks like beyond the city, right? Like if there was all that smog, we would see this in the sky. Right. It's kind of interesting to think about what's beyond, what you can see. Mm-hmm.
Well, we sure appreciate everybody joining us today. We hope that you're able to take these and modify it to something that's going to work for you. And please let us know if you have questions or feedback for us. We'd love to hear it. And we hope to see you after our break. I think 1 p.m. today we'll be doing waves.
Does everybody hear that?
Sounds like everybody's leaving. So
yeah.
And also thank yous. Okay.